What if I told you that every time two black holes collide, they leave behind a cosmic fingerprint that could rewrite physics as we know it? Imagine the most violent event in the universe, two black holes, each millions of times heavier than our sun, spiraling toward each other at nearly the speed of light. When they finally merge, they release more energy than all the stars in the observable universe combined. But here's what most people don't know. The real magic happens after the collision. This is where ringed-on waves come in. Think of it like dropping a pebble into a pond. You see the initial splash, but then there are ripples that spread outward. Ringed-on waves are those cosmic ripples, the final vibrations of the newly formed black hole as it settles into its perfect spherical shape. Scientists call this process ringed-on, because the black hole literally rings like a bell, emitting gravitational waves that carry information about its properties. What makes this so revolutionary is that these waves act like cosmic fingerprints. By analyzing the frequency and decay rate of these vibrations, physicists can determine the black hole's mass, spin, and even test whether Einstein's theory of general relativity holds true under these extreme conditions. The detection of ringed-on waves was one of the most significant confirmations of Einstein's predictions. But here's the twist. Recent observations suggest these waves might contain secrets Einstein never imagined. Some physicists believe that ringed-on waves could reveal the existence of exotic matter, extra dimensions, or even prove that black holes aren't actually black holes at all, but something even stranger called gravastars or fuzzballs. The way we detect these waves is nothing short of miraculous. Using instruments like LIGO and Virgo, which are essentially the most sensitive rulers ever built, we can measure distortions in spacetime smaller than 1/10,000th the width of a proton. When a ringed-on wave passes through Earth, it literally stretches and squeezes space itself. The reason ringed-on waves are so crucial is that they represent the final moments when the black hole sheds all its imperfections and becomes perfectly smooth. According to the no-hair theorem in general relativity, black holes can only have three properties: mass, charge, and spin. Everything else gets radiated away in these gravitational waves. But what if we find deviations from this pattern? That would mean our understanding of gravity is incomplete. Some of the most exciting research happening right now involves looking for echoes in the ringed-on signal. These would be repeated patterns that shouldn't exist according to classical physics, potentially indicating that black holes have a surface or structure instead of being featureless voids. The implications are staggering. If we confirm these echoes, it could mean that information isn't lost in black holes as previously thought, solving one of the biggest paradoxes in modern physics. Every time we detect a ringed-on wave, we're essentially listening to the universe's most fundamental secrets. These waves travel across billions of light years, carrying messages from events that happened when Earth was still forming. They're not just scientific curiosities, they're direct probes into the nature of reality itself. The next generation of gravitational wave detectors, like the space-based LISA mission, will be so sensitive that we'll be able to hear ringed-on waves from the earliest moments of the universe, potentially revealing how the first supermassive black holes formed. We're living in the golden age of gravitational wave astronomy, where each detection brings us closer to understanding the true fabric of spacetime. What cosmic mystery do you think ringed-on waves will reveal next? Drop your predictions below.